Hello all my dear students, I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. In the very last class we have discussed about the dielectric material. We had two types of the dielectric material, right? One was polar and another was non-polar dielectric material, and we have discussed all the how the polar and non-polar works when they are kept in any of the electric field, right? In this particular lesson we start with the capacitor, right? Basically the chapter is divided into two, right? The chapter is electrostatic potential and capacitance, right? Electrostatic potential is completed, right? And capacitance we have started the very last class, right? The very first topic in the capacitance is about dielectrics that we have seen in the very last class, right? Now this will be the second topic under capacitance. Now we are dealing with the capacitance section, right? Now what do you mean by capacitor? Do you know what capacitor is? Capacitor is a charge storage device, or it can be said as it is an energy storage device, right? Then what is the difference between what is the other device that stores the energy? It is a battery or a cell, right? So what is the difference between battery, cell, or you can say the capacitor? How the battery is different than the capacitor? Capacitor is an energy storage device, right, where the energy can be instantly used and it discharges completely within no time, right? But battery provides energy very slowly to the circuit and it discharges, and it takes certain time to discharge completely. So for example, you can say a battery, depending on the capacity of the battery, it might take 2 hours, 3 hours, 4 hours, right? If the capacity of the battery is high, then it may take a long time to discharge, right? But the capacitor, once it stores the energy, and when you use that particular energy, it instantly discharges and completely become null, right? And hence this is a difference between the capacitor and the battery, right? Now what do you mean by storing the energy? It means storage of the charges, right? For any particular region, when we are storing the charges into that particular region, it is filled with the charges that is again filled with some particular energy, right? So let us understand how it is, right? Say for example, now this you have this region, right? Now if at all you want to store energy into this particular region, then you have to get the charges from the distance of infinite to this particular region. This concept I have explained you in the very last classes, right? Whenever we get, what do I mean infinite distance? A region, it is not, it really doesn't mean that we are getting a charge from a very far distance. It only means from a region of no energies, from a region of no electric field at all. When the region has no electric field or any region acting into that particular space, then that space we call it as infinite region, right? If at all you want, now initially this region is empty, right? You will get a charge, say Q1, right, and bring here and place here. Now Q1 charge is present. Initially the space was empty and there was no charge and there was no electric field into it, or there was no energy into this particular region. When any of the charge that is brought from the region of zero electric field to this particular region, now what happened? What is the work done in bringing the charge from one point to the other? We always require work done in bringing the charges from one region to other, right? If at all we are moving into a region of no electric field, then the work done will be equal to 0, right? Initially there was no electric field and hence we have brought the charge into this particular region. The work done will be equal to 0 here. Why? Because electric field was 0 initially, right? Now when you get a charge here, now it sets some electric field around it, right? It sets some electric field. Now the region is not empty, it has some electric field due to the charge 1. Right? Now you take another charge, say Q2, and get into this region here, right? Now Q2 has to move against the electric field that has been provided by Q1, then there should be definitely some work done in moving that particular charge from this region to this region, right? And hence some work will be done. What is that done? What is the work done in moving the charge from here to here? Say for example W1. Right? Now you have another charge Q3. Now this particular charge has to move against the electric field of 1, against the electric field of 2, then there is more work done, right? So the moving the charge Q3 to this particular region, it again has to be work has to be done, that is called W2. Now W2 will be, now the work done in bringing the Q3 charge will be more, or Q2 charge will be more, Q3 will be more, right? Why? Because the Q3 has to move against the electric field that is produced by Q1 and also against the electric field produced by Q2, right? And hence definitely the energy required in moving against that particular fields is more, and hence work done is more, right? Now why we are getting all the charges and we are storing here? Any amount of the work done that has been made in bringing the charges from the region of infinite to this particular region, that particular work done will be stored in the form of potential energy. Then what does this mean? More the amount of this energy storage, or more the amount of the charge storage, more will be the work done. More will be the work done, that work done will be stored as a potential energy of that particular device. So why are we doing all these things? We want some energy to be stored in some particular device. So what we do, we get many amount of the charges from a region of infinite and store in some particular energy, where all the work done will be stored as potential energy of that particular device, right? Once the potential energy is stored in this device, this can be used as a storage device and can be used in the electrical circuit, and whenever you wanted that energy, this potential energy can be used. Now you understand why these things are done, right? Potential energy is stored to use whenever we wanted into any electrical circuit or any applications, right? And this is the basic idea of the capacitor, right? Now this idea is for both capacitor and the battery, but what makes them differentiate is battery is used very slowly in the circuit. Whenever you wanted any circuit to be energized or to supply the energy very slowly, then battery is used, battery or the cells, depending on your application. Either you use battery or either you use cell, right? If at all you want in your circuit, you want instant energy, right? Instant discharge of energy, then you use capacitors. Now this is a capacitor where the potential energy is stored into itself, and this is an energy storage device. It is used in the electrical circuits. Whenever you wanted an energy instantly, then you use capacitors. Now give me example where the capacitors are used, so that we can just imagine how the energy is instantly discharged. You have seen the very conventional type of the cameras. Even today we use a camera, right? You have a flashlight over there, right? Where do you get the energy for that flashlight? Flashlight is operated only once, right? In a one click it discharges the energy. There you use the capacitor, right? The flashlight is not completely turned on for a very long time, right? You just take a picture, the flashlight flashes it on, and then the energy of the capacitor is completely discharged in turning on that particular light. Whenever you charge any conductor, it stores the charges, right? Then it means all the bodies which stores the charges are definitely capacitors. Yes, they are definitely capacitor. If at all you speak about the spherical body, when you charge the spherical body, all the charges are accommodated on its surface, right? Now what does this mean? A charged sphere is storing some particular energy. Now this can also act as a capacitor, right? But practically what we follow always is we have a charged plate capacitor like this, right? We always take a plate capacitors, right? Say for example, initially it had no charges, then later on you have charged it positively, right? Later on you have charged it positively. Then see, whenever I say you can charge a conductor, it doesn't mean you can go on giving the charges and it accommodates on its surface. No, right? It has some capacity, or it has some value up to which you can. It has some capacity up to which you can charge. If you charge over and over, then it gets the surrounding air gets ionized. Say for example, say this is a glass of water. Right? Now you are pouring a water. In that water you say it is considered as charges, that you are pouring the charges, right? Now it starts filling the water, right? Now say this level will be potential, right? And this particular glass has the capacity, right? Some certain amount of the capacity. You cannot always pour the water or pour the charges into the glass. It has some certain value or some capacity. if at all it had filled up to this particular point, and if you again go on increasing the water level, it will definitely pour down, right? And hence this can be seen even in this plate, right? There is a limitation to charge this plate. Overcharge will not be taken on this particular surface, and hence if you charge again on this surface, the charges will left out and the surrounding area will get ionized, which we do not want it, right? This is all again it is very hazardous, it is not proper, it is not a convention to follow, right? So we have to charge the body only up to its maximum capacity, beyond which it cannot hold, right? Now say for example, this is the glass, these are the charges, and this is the potential level it has filled. Now you cannot put further charges into it, right? The capacity of this particular glass is only this much. Now what if you want to put, or you want to have more charges into this? Then you increase the capacity, right? They increase the capacity of this particular glass. How do you increase the capacity? By increasing its area. Let this potential be the same, but you increase the capacity, right? You make it little wider, right? When you make it wider, the potential will set down here, and it has some more area so that the charges can be poured here, right? So what we are doing, if at all the capacity of any of the capacitor is decreased, then what we do, we increase the capacity of that particular capacitor by decreasing the potential. Initially the potential was this much, now the potential is this, right? If at all you can decrease the potential, then there is more space to get the charges or the water that is poured, right? So if at all you can decrease the potential and increase the capacitance, more and more charges can be accommodated, which again increases the capacity of that particular plate, right? Let us understand with the example, it makes you very clear. Say for example, this is a plate, right? Initially it was not charged, later on we have charged it to the 5 coulomb, right? Now the capacity of this particular sheet is 5 coulomb, sheet or a plate is 5 coulomb, beyond which if you pour the charges or you charge this particular area, then the charges will be distracted, or they will be diversified into the atmosphere and make the surrounding ionized, which is not desirable at all, right? Now what we do, we have to increase the capacity of this particular plate, right? The plate remains same, but the capacity has to be increased so that the same plate will further accommodate 10 coulomb into it. How the plate capacity is increasing? By decreasing the potential. How to decrease the potential? Let us understand. You are getting my point, right? Why are we decreasing the potential of the plate? Why? Because we wanted a high capacity. When the capacity increases, the amount of the energy storage increases, right? Lesser the capacity, if at all it only 5 coulomb of charge, then it is less capacity, right? If at all the same plate is charged to 10 coulomb, then it means the capacity has increased definitely, right? And now it is no more capacity and it can hold more energy into it, right? With the same plate given, we have to decrease the potential and increase the capacity so that it can store more and more amount of the energy, right? So how do you do it? Let us understand. Is this clear up to this point? Okay, how we decrease the potential? So understand first. Now this is the plate. Initially it was a neutral plate. Then we have given a charges of positive, right? Right? Now this is exactly the plate what we have represented here. Now what you do, you bring another plate near to it, which is again neutral. You get another neutral plate near to it, right? Due to the effect of induction, this is a neutral plate where positive charges and negative charges are equal in amount, and hence it is called as neutral. When the neutral plate is kept in this particular region of or near this plate, then what happens? Due to the induction, these are positive charges, all the negative charges attract on the left side of the plate, right? And the positive charges, due to this positive and positive, they repel, and all the positive will be accommodated on the opposite surface, right? So what do? Why we are doing all these things? We are decreasing the potential of this particular plate so that the capacity of holding the charges or energy increases, right? Now the plate is being kept, charge plate is kept, another plate is kept here. Due to the process of induction, all the positive charges attract the negative charges, and hence the left side of this plate will become negatively charged, and the positive charges which are present in this particular plate, due to this repulsion, they are accommodated on the positive, that is right side of the plate, right? And hence the second plate has to be grounded. Why? Because ground will take any excess amount of the charges into it, right? Now ground has the negative charges. The negative charges come and nullify all these positive charges, and hence this plate completely becomes negatively charged, right? And now you tell me, what is the potential? Now this was the process, right? What is the potential of the plate A, right? Initially, when this was not there, initially this is plate A, this is B, right? Initially V was equal to V1, right? Or you can say V was the potential at this particular point, right? When this potential plate is brought, right, what is the potential of this particular plate? In the very last classes, I have clearly explained you why it is very important to have the potentials with their polarity. Why? Because whenever you have positive charges, the positive potential is created around the body or the object, and if at all you have a negative charges on the body, then the negative potential is created, right? The potential that is created in the plate A will be positive. Why? Because it consists of only positive charges, right? And the potential on the plate B will be negative. Why? Because it consists only in the negative charges, right? And hence the potential of plate A, when this was not available, right, when it was only single, then it was a potential V, right? Now when the another body, that is another plate B has kept, what is the potential of this? It is minus V1. Why it is minus? Why? Because the potential is because of the negative charges, right? Now whenever you want to calculate the potential at some particular point, then what you do, you have to calculate you have to add up all the potentials that is around, right? So if at all you want to calculate what is the potential here, then potential at this particular plate A, VA, will be equal to V plus of minus V1. We are calculating what is the potential at this particular plate. So it has two potential now. Potential because of its own charges, that is positive charges, you have V, right? And it also has the potential because of the negative charges that is influenced by the plate B. The potential at B will be minus V1. So the addition of this potential and this potential will be the total net potential on the surface A, right? So the net potential on A will be V plus this potential. This can be explained or this can be understood with a very good example. Say for example, this had initially a potential of 10 volts before the plate is introduced, right? After the plate was introduced, say for example, this had a potential of minus 5 volts, right? Now you substitute the values. Initially it had 10 volt plus of minus 5 volt. It is 10 minus 5 is equal to 5 volt, right? Now you please do make a note here. What we are supposed to do, we are decreasing the potential of the plate so that it can hold or it can increase its capacity of holding the stored energy. Initially its potential was 10 volt. After introducing the plate, that is negative plate, in its vicinity, then the potential has decreased to 5 volt. Now what is the potential of this particular plate? It is 5 volt, right? The potential has decreased to 5 unit, right? Then if the potential has decreased to 5, initially it was 10. Here it can be understood. Initially it was 10. Now it is reduced to 5. Due to which what happens? Capacity of this has increased. By decreasing, you can look here, by decreasing the potential of the capacitor, you can increase the capacity of any capacitor, right? And hence this is the logic, or you can say the principle of the capacitor, right? Now this is how the capacitors are designed. Whenever you want to design a capacitor, you should always have two conductor. One is positively charged and another is negatively charged. The negative plate will be always grounded. Right? Why we use the second plate? We can have only one particular plate and have the capacitance, right? It can be done. But the thing is, if at all you want to increase the capacitance or the capacity of the storage of the energy, then the other second plate has to be introduced, and it should be negative in nature and it should be grounded, right? This second plate will first drop down the potential in the first plate and also increase the capacity of that particular plate. Is this clear up to this point? Did you understand? Okay. If at all you want to find out what is the capacitance of the sphere, then how do you find out? Say take a sphere, you charge that sphere with the positive charges, and hence the charges that are present on this particular sphere, say it is Q, right? And the radius of the sphere, let us take it as R. Right? Now how does the capacitance factor calculated? You know that C is equal to Q by V. Now you know what amount of the charges that are present on the sphere? It is Q charge. We know this quantity, right? Now what is this V? This is a potential, right? Potential of that particular sphere. Now what is the potential of the sphere? The potential of the sphere will be given as KQ by R. Q is the amount of the charges that are present on the surface. R is the radius from the center to the outer line, and K is the permittivity, right? And hence, if you can remember, this is a equation for a point charge at some particular point. If you want to find out what is the potential, we had got this, right? Now this is taken, now this complete sphere is taken as point charge. Why? Because it is the symmetry. Why? Because of the symmetry. Wherever the point you consider, whichever point you consider, the potential remains same at any particular point, right? If you increase the radius, right? If you increase the radius of the sphere, then the charges accommodation will also be increased, and hence due to its symmetry, and at any point you find the equal potential due to this particular symmetry, this sphere is considered as a point charge, and hence the potential at any point due to point charge will be equal to V is equal to KQ by R, where Q is equal to the charges that is accommodated on the outer surface and R is the distance between the center and the outer line, right? And hence what is this value? K is equal to 1 divided by 4 pi epsilon, that is Q by R, right? This is the value, right? Now substitute the value of this V into this equation. So what do you get? C is equal to, right, Q divided by 1 divided by 4 pi epsilon Q by R, right? This Q get cancelled, and capacitance of the sphere can be written as 4 pi epsilon into R, right? Here it is very clearly understood C is directly proportional to R, right? As the radius increases, as the radius of the sphere increases, the capacitance or the capacity of this particular sphere goes on increasing, right? Now you can even calculate what is the capacitance of the earth, right? Capacitance of the earth can be written as again the same formula, 4 pi epsilon into R. What is the radius of the R? Radius of the R is 6400 kilometer. What is this value? 4 pi epsilon naught is 1 divided by 9 into 10 raised to 9, right? Now substitute both the value in this equation. What do you get? 1 divided by 9 into 10 raised to 9 into 6400. Converting into meter, it is 10 raised to 3. Now the capacitance is 711 microfarad. The earth capacitance is C is equal to 711 microfarad. Is this understandable now? Right? Now you have learned in this particular class, you have learned about what capacitors are, what is the principle of the capacitor, how the capacitors are different from the batteries, right? And how the capacitance of the sphere is found out and how the capacitance earth is found out, right? And I hope this is all understandable for you. In the very next class, we will deal with the combination or the connection of the capacitors. If at all the capacitors are connected in series, then what is the capacitance you get? What is the nature of capacitance, whether it is increasing or decreasing? Or if at all you connect a capacitor capacitors parallelly, then what is the effective capacitance, whether it is increasing or decreasing, and how the other nature and the behavior of the capacitor when it put into any electrical circuit. That is learnt in very next class, right? This was all about today's class. I hope you people have understood. You please share and subscribe to my channel, share with all your friends and family, right? And the material for this particular chapter will be given into the description box. You can go through, visit my website, download the notes, and you can study on your own, right? And hopefully everything is clear from my end. If any suggestion, you please drop down your message, and I'll be very grateful for all your comments and your positive feedbacks, right? And thank you so much.